So throughout this video, we're going to learn about expressions that contain exponents or powers and how to evaluate those particular expressions. So to start, we're going to take a couple of notes on exponents. So here it says exponents are used to represent what is called repeated multiplication. So it's just a fancy way of representing something being multiplied by the same value multiple times, something that's being repeated. Now, inside of this exponent, and you can see you have 3 raised to an exponent of 5. 3 is called your base. So it's the base number. It's the number that is being repeatedly multiplied. And then the 5 is called your exponent, or sometimes referred to as a power. And it basically says how many times the base is multiplied by itself. So what this exponent problem is actually saying is take this base of 3 and multiply it by itself 5 different times. So this is called exponent form, and when we actually write out the repeated multiplication, this is called expanded form. So what this really means is we're taking 3 and we're going to multiply it by itself 5 times. So this means 3 times 3 times 3 times 3 times 3. So we can write it in exponent form, or we can write it into expanded form by using what the definition of an exponent actually means. Now, in words, the way that you should be saying this is 3 to the power of 5, or you can say it as 3 to the 5th power. But that's how you'll hear it in the world of mathematics. So be aware of those vocabulary terms and how to convert from exponent form into expanded form. Now for each of these problems below, all we're going to do is write it from exponent form into expanded form. And if it uses parentheses, we're going to use parentheses simply because it will prevent us from making any errors in the long term. So here we have 4 to the power of 5, so that means 4 times itself 5 times. So we should see 4 5 different times. 6 to the power of 9 is 6 times itself 9 times. So there's 5, 6, 7, 8, 9. So you can see where exponents are nice because writing 6 to the power of 9 out in expanded form can be a bit difficult. Then this next one is negative 0.5 to the power of 4. So what this is showing you is that negatives, if they're in parentheses, can be raised to a power as well. And then this last one is 3/4 to the power of 3. And this one, I should be putting my multiplication symbols in there, but these are meant to show you that you can also apply exponents to fractions. Just make sure you put them into parentheses to imply that that power of 3 goes to the entire fraction. Now on this slide, we're going to take the expanded form and write it into exponent form. So here I see 5 being multiplied by itself 4 times. So this would be a base of 5 to the power of 4, because there's 1, 2, 3, 4. Then here I see negative 7 in parentheses, so I'm going to keep it in parentheses to keep that negative with the 7. And then I see 1, 2, 3 times it's being multiplied by itself, so to the power of 3. Then here I see 1, 2, 3, 4, 5, 6 ones, so this is 1 to the power of 6. And then 1, 2, 3, 4, 5, 6. Here we have negative 2 in parentheses to the power of 6. So writing it from expanded form into exponent form is a nice way to kind of condense it down and make it a little bit smaller to look at. And lastly, we're going to take the math statements below and write them into exponent form. So sometimes being able to just read them or to be able to understand what a vocab term means can be a really important math skill. So here we see 4 squared. Now squared is a fancy way of saying power of 2. So this is really 4 to the power of 2. That's what squared means. Then from here, 7 cubed. Cubed is a fancy way of saying power of 3. So this is really 7 to the power of 3. Then this one is 2. That's our base to the 6th power. So we have 6. And 3 is our base to the 4th power. So you see 4. So here we're going to practice actually evaluating exponents without a calculator, and the easiest way to do this is to start by writing each of them into expanded form. So here I see 3 to the power of 3, which I know is 3 times 3 times 3. So I start by writing it into expanded form, and then I apply what I know about multiplication, which is that I multiply from left to right. So I start by multiplying these two 3's together, which is 9, so they've been evaluated. And I'm left with 9 times 3, which becomes 27. And then from here, 8 to the power of 2 is 8 times 8, which I know is 64. Then here, negative 2 to the power of 4, so I'm going to write negative 2 times negative 2 times negative 2 times negative 2. And then again I evaluate from left to right. So here I start with these two negative 2's. A negative 2 times a negative 2 is a positive 4. And then from here, well, 4 times negative 2 is a negative 8. And negative 8 times negative 2 is a positive 16. And then finally here we have negative 1 times negative 1 times negative 1 times negative 1 times negative 1. So I start from left to right. Negative 1 times negative 1 is a positive 1. So I still have 3 more that I need to evaluate. So 1 times negative 1 is negative 1. Negative 1 times negative 1 is back to a positive 1. And then that final multiplication of 1 times negative 1 is negative 1. So you can see just writing it out and going from left to right can really help and prevent you from making any sort of error. So this final slide just shows you the different applications of exponents. So you can see here it says find the area of the square. So I have the area equation for a square, which is just side squared. So here we have a side length of 9, so our area would be 9 squared, which is 9 times 9, which is 81. And then if we tack our units on, it should be 81 inches squared. Then from here, we have a square with a side length of 12. So I know it's 12 squared, which is 12 times 12, which is 144 inches squared. Now if I look down at volume, volume is the side length cubed. So here we have a cube with a side length of 10, so my volume would be 10 cubed, which I know is 10 times 10 times 10. And then if I evaluate from left to right, 10 times 10 is 100. And then 100 times 10 is 1,000, and that would be then millimeters cubed because our 10 was cubed. And then finally our volume of this cube would be 3 cubed, which is 3 times 3 times 3. Well, 3 times 3 is 9. Then 9 times 3 is 27, so we have 27 feet cubed.